Here, we're being given a quadratic function. Quadratics have x squared. And we're being told what the x-intercepts are. The x-intercepts are the places where y equals 0. Now, the x-intercepts of a parabola are important because from there you can get the factors. For instance, let's just say, this is not related to this question, but let's say we had this quadratic and we're told to find the x-intercepts. We need to know that the x-intercepts mean that y is 0. So you set y equal to 0. Now that enables you to factor. This would factor to x minus 7, x plus 5 equals 0. Then the zero product rule says that if these two things multiply together and give you a 0, you can set each one equal to 0. And now you can solve each one, add 7 here, and take away 5 here. So this is what we refer to as the quadratic sequence. It's just the basic idea of what you do when you have a parabola and you're factoring to find the x-intercepts. Here we have the factors, these things in parentheses, and at the bottom, these two things, we call them roots or x-intercepts. So now, why does this matter? In our question, we're being given the x-intercepts, x equals 7 and x equals -3. And we can work it in the other direction. Well, we already saw in my example that if x equals 7, the factor is x minus 7. But if x equals -3, the factor would be the opposite sign, x plus 3. So right now, we have a quadratic with two known factors. So we can kind of write it. Let's go ahead and make some space. We can say our function may or may not have a coefficient in the front. So let's put a little letter a there. And actually, we know it does because there's the a right there. But we know it has these two factors to it. We can start working on this. We can FOIL this out. First times first, outer times outer, inner times inner, last times last. And we still have an a to take care of here. Combine like terms, x squared minus 4x minus 21. Now multiply in the a. Ax squared minus 4ax minus 21a. Now, this is a quadratic in the format of ax squared plus bx plus c. And we're being asked for a plus b, which means we have this plus this. In other words, for us, this added with this. And one of them is a, the other one is -4a. So if we add them, we'll get -3a. So which of the following could be the value of a plus b, adding these two coefficients? And for us, that looks like -3a. Now, what are the rules of what we're doing? We're simply being told that a must be some integer that is greater than 1. So the question is asking us, which of these four answer choices can we set this equal to? Can we set it equal to -6, like answer choice A? Can we set it equal to -3? Can we set it equal to 4? Or, last but not least, 5. And if we solve all of these, here if you divide by -3, you'll get 2. Here if you divide by -3, you'll get 1. Here, divide by -3, you'll get -1 1/3. And here, you'll get -5/3. So the restriction was simply that a had to be something greater than 1. So this one here was really close. It's exactly 1. But this one here, that's the one that worked. And that's answer choice A. If we set our a plus b that we found equal to -6, a ends up being greater than 1. And so the answer is A.